Okay, this lesson discusses how to factor polynomials. You can see we've got quite a few different techniques to look at. Factoring polynomials is an extremely important technique to learn. You'll use it throughout this class, throughout calculus and beyond, in really any math or hard science class you take requires you to factor. So this is a really good skill to practice and get good at. It will save you a lot of time and headaches if you can factor well. First technique, and the first thing you should always try to do when you're factoring anything, is to pull out something they all have in common. So you're factoring out the largest piece that each term has in common. Remember, terms are the things that are separated by the pluses and minuses, right? These are our terms, and in this case they all have a 6 in common. Now if you don't see that, if you don't recognize they all have a 6 in common, that's fine. Just find anything they have in common. So in this case, maybe you recognize that they all have a 2 in common. And then what's left over? 9 plus 6x minus 3x squared. And then you look at that and go, hey, now I can recognize there's a 3 in those. So you've got 2, and then you take out the 3, and you're left with 3 plus 2x minus x squared. Of course, you put the 2 and 3 together, and you're right back to the same exact answer that they had. And you just did it in 2 steps instead of 1, and that's fine. It doesn't take you much longer to do it. So don't worry about trying to find the largest thing they all have in common. Just factor out whatever they have in common and just keep doing it until they don't have anything in common left. Factoring by grouping. This really works whenever you have polynomials with degree greater than 2, and it really only works well if you have 4 terms. If anything, they've got to be even, right? You have to have an even number of terms. So you can do this with 6 and 8, but it gets kind of clunky and messy. So, to help you recognize when to try this technique, whenever you see 4 terms, go ahead and give it a try. Now you can see in this example, the first thing they did was they grouped the first 2 and the second 2. That's not always the case. You don't always have to do that, and it won't always work that way, that the first 2 have something in common. The bottom line is you have to factor it in such a way that the 2 terms have something in common that you can factor out, and the other 2 terms also have something in common that you can factor out. So maybe you thought, well, I'll factor it differently. Instead of factoring it with those 2, let's try factoring these 2 and then these 2. Well, the middle have a 5x in common, but the outside have nothing in common. So you go, oh, darn it, that doesn't work. So instead, you have to try something else. So how about these 2 and then those 2? And you go, well, those have something in common, those have something in common. Yeah, that'll work. Okay, so x cubed minus 10x, and then over here we have 5x squared minus 50. What do they have in common? They both have an x, right? You're left with x squared minus 10. Over here, what do they have in common? Only a 5. You're left with x squared minus 10. And lo and behold, these 2 things match. If the factoring is going to work, once you factor out the terms, the leftover pieces have to be the same, right? If they're not, then this thing doesn't factor. So now you put together the outside pieces, right? So I have an x plus 5 on the outside of those 2, and on the inside, x squared minus 10. Just like here, they had an x squared and a negative 10, which gave you this piece, and then the x plus 5 for both of them. And you can see that both answers are exactly the same, right? Just in a different order, but the same thing. So if factoring works, it will work in either direction, if you want to think of it that way. The bottom line is you can just pick any 2 that you like that have something in common, as long as the other 2 terms also have something in common. go ahead and go with it. There's no rule that says picking these two is better than picking those two, etc., etc. So just don't be afraid, jump in, give it a try, and it's either going to work or it's not going to work. Okay, trinomials of this type, of that form. Yes, these are trinomials. They're called trinomials because they have three nomial pieces, right? It's a polynomial with three pieces. But really, you're going to hear these called quadratics more than anything else. So when you hear the term quadratic, that's what you're looking at. And you might remember the quadratic formula. It's used to solve this, for factoring this, for finding zeros. Okay, so if you don't recognize this, this is plus or minus. That's what these little symbols mean. So anytime you have a quadratic or a trinomial of this form, right, where a, b, and c are numbers, and plus or minus, then you can use this three simple set of steps to try and factor it. Now, if this is of a certain form, there are certain things that will be easier and more difficult. And you can, as you get better, you'll learn shortcuts for when these things are of slightly different forms. You know, like when a equals 1, there's a shortcut. You'll start to recognize that whenever this is a minus and whenever this is a plus, you do a certain thing, or whenever this is a plus and this is a plus, you do a certain different thing, etc., etc. But I like to keep it simple and give you one technique that works for all of them. And this is the best way to handle any of them. So let's start with a real simple one. Let's start with x squared minus 5x plus 6. So in this case, what does a equal? That's right, a equals 1. So this is one of those kind of subcategory cases. When a equals 1, it gets a lot easier, but still, the first thing you do is look for a common factor. They don't have anything in common, right? There's not something that all three things have in common. So you can't factor it out. So the next thing you try is factor out a. You know, there's nothing there, right? A is just 1, so factoring that out doesn't really work. So now you basically jump straight down to the third step. Find the factors of c. So c is 6. So the factors of c are going to be 1 and 6, or 2 and 3. And then you look for their sums and differences, right? So the sum of these is going to be 7. The difference of them is going to be 5. The sum of these is going to be 5. And the difference is going to be 1. And we're looking for the sum or difference to equal b. So both of these seem to work. But b is actually negative 5, right? So how do we get a negative out of these? Well, what we want to remember is we get a quadratic because we took x plus some constant and multiplied it by some other constant. Call it d or whatever. And when you multiply these out, if you FOIL it out or you do our nice systematic multiplication thing, you get x squared, right, plus d times x plus c times x, and then plus cd. But what happens if it's x minus c and x minus d, right? Then you get x squared minus dx minus cx plus, we still get plus cd, right? Because negative c times negative d is still positive. Look what happens when you have x plus c times x minus d. X squared plus cx. Sorry, I should do this the same way so you see the pattern. It's going to be x squared minus dx plus cx minus cd. And then last but not least, what if we have x minus c times x plus d? Then we get x squared, right, plus dx minus cx minus cd. So you can kind of see the pattern. Whenever both of the symbols are the same, right? They're both plus or they're both minus, the end result is a positive number, right? Plus CD. Remember, CD is just going to be a number because C and D are both constants when you multiply. So think of them like 2 and 3, and when you multiply them together, you just get 6. So those two will both have plus a number at the end. Whereas when they're opposite signs, you always get a negative. So when you have a positive 6, what does that tell you about our factors? It either has to be plus and plus or minus and minus. So that means we're looking for either positive 1 plus positive 6 gives us that, or negative 1 plus negative 6 gives us a negative of that, right? Positive 2 plus positive 3 gives us a positive 5. Negative 2 plus negative 3 gives us a negative 5, right? So when the symbols are the same, you're looking for a sum. And then you just get a plus or minus, whether if you're adding two positives, you get a positive. If you're adding two negatives, you get a negative. When the symbols are different, right, when they're opposite, you're looking for a difference because you end up getting one of these is positive and one of these is negative. So you're just subtracting one from the other. And you'll either get, right, 1 minus 6, which gives me a negative 5, or minus 1 plus 6, which gives me a positive 5, right? A 1 minus 3 gives me a negative 1, or a negative 2 plus 3 gives me a positive 1. So you can see that you always get a difference whenever you have the blue situation, and you always get a sum whenever you have the yellow situation. So because we have a yellow situation, we know we're checking for which one of those two numbers work. We see that 5 works, and because we want a negative 5, we know it has to be negative negative, right? So it has to be x minus 2 times x minus 3. Whew! I know your brain is probably sending out smoke at this point, going, how the heck am I going to remember all that stuff? Well, if you don't want to try and remember patterns, then what I would suggest is just list out all of the possibilities. Instead of just doing 1 and 6 and getting 7 and 5, go ahead and do all the possibilities. 1 and 6, negative 1 and 6, 1 and negative 6, negative 1 and negative 6, and look at all of those. And do the same thing with 2 and 3's. So you can just play around with the pluses and minuses until you start to see how certain pairings are the same. Okay, let's try one more. So let's do, how about x squared plus 2x minus 24. So let's go back up and look at the things that we kind of wrote before. So if we have, and I'll write it on this slide so you don't have to remember what it was, if we have x squared plus 2x minus 24, right? We've got a minus 24. So are we in a blue situation or a yellow situation? And hopefully you're all recognizing we're in a blue situation, right? So that means our factors are going to be opposites, right? One's going to be plus and one's going to be minus. So when we find the factors of C, we're going to be looking for differences. Okay, so let's go back to this slide. And remember, first thing we do is try and factor something out, nothing in common. Then we factor out A. A is just 1. So the next thing we do is find the factors of 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then it'll start repeating, right? 6 and 4, 8 and 3, da, da, da. So we're done. And as we realized from the previous slide, we're looking for differences. So differences, they're either going to be plus or minus 23, right? Because it's either going to be a positive 1 minus 24, or it's going to be a positive 24 minus 1. So 2 and 12 gives me 10, 3 and 8 gives me 5, and 4 and 6 gives me 2. Ding, 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 we have a winner. This is our pair right here. So we know it's going to be x and 4 and x and 6, and because we need a positive 2, which of these two gets the positive? Well, it's got to be the bigger one, positive and negative, right? Because then we get plus 6 minus 4, that gives us the positive 2. And you can always FOIL it out and double check your work. Okay, so that's kind of the generic way. If you want to practice that, that's the best thing. The book is going to break it down and it's going to show you specifics. Whenever you have something of this form, do this. Whenever you have something of this form, do that. And then you've got 5 and 6 different techniques to try and memorize. And I think it's better to just have one general technique. So how would our technique work here? Same thing. You recognize that the last one is positive. So if you remember the colors, right? Positive puts us in a yellow situation, so they're the same, right? They're either both positive or both negative. We do our factors of that, 1 and 4, 2 and 7. And because they're both the same, we're looking for sums. And lo and behold, that is what we found, right? The sum works there. Those are what we want. Since this number is positive, we know that they both have to be positive, right? They have to be the same symbol, and because that's positive, they both have to be pluses. And that's how that works. Okay, what happens when all of a sudden we have something where a is no longer 1? Right? Remember, here's my a. These are ax squared plus bx plus c. A is not 1, so the first thing we do is try to factor what they have in common, and lo and behold, in this case, they all have a in common. So you're basically factoring out a, and now you're left with something that's exactly of the form that we did before. So we're back to doing those steps. It's a plus, so we're looking for a sum, right? We're looking for something that's the same. Find the factors of 24, 1 and 24, 3 and 8. They obviously, 2 and 12, 4 and 6. They put minuses in here ahead of time because they knew they had to be minuses because of that. And if you want to do that, that's fine. You could also just work with normal numbers, get answers of 25, 11, 14, and 10, and realize, oh, 10's the one, but because this is a minus, they're both minus signs, and then there's my factoring, and then I don't forget the 2 that I pulled out in the very beginning. Okay. So here is the step that the book gives you for trinomials of the type that we just did. I don't like it. I don't like the FOIL method. If you want to study it, that's fine. I say stick with the method we did. So here's an example of the FOIL method. If you want to come back and look at this, go ahead and pause the video and take a look. The grouping method, or the AC method, also, it can be handy at some point, but it's just one more method for factoring something of the same shape, right? We're still factoring this. So do you really want to learn 3 different ways of factoring the same thing? I don't think so. Here's an example. If you do want to do it, go ahead, pause the video and read through this. Okay, special factorizations. This is basically just reminding you of some of those special products that we saw in a previous video, that when we see things of a certain shape, if you can remember that they factor a certain way, it will save you time. But if you don't, then you can always just play around with it. Anytime you see a difference of squares, that's what this is. Something squared minus something else squared. Then you always get perfect conjugate pairs. A conjugate pair means that they are the same, but with a different symbol, right? So plus and minus. So a plus b, a minus b, that gives you a perfect square. So let's say you had 4x squared minus y to the 4th. Can you recognize what the perfect squares are? All right, let's take it up a notch. Can you see two things in each, right? One on each side that is something squared, i.e., what's the square root of this piece? What's the square root of this piece? If they have perfect squares, then it fits that pattern. So if you take the square root of the left side, don't you get 2x? And if you take the square root of that, don't you get y squared? There you go. There's your conjugates, right? So we can expand our thinking, and instead of just a simple example like this, we can do something a little more advanced, but it's still the same idea. You're looking for two perfect squares. The next special one that you'll come across a lot are these special kind of quadratics. Quadratics that are of these two forms are these perfect squares. So you might want to, again, try to memorize them, but I'm not a big fan of memorization, so it doesn't matter. If you still just use those same 3 steps we used before, this would work, right? So for instance, let's use our 3 steps we did before. There's nothing in common, so there's nothing to factor out. A equals 1, so dividing by that doesn't help. So now we go to here and go, all right, it's a plus, so I'm looking for a sum. I do the factors of 36, 1 and 36, 2 and 18, right? 3 and 12, 6 and 6, and because it's a plus, right, I know we're doing the same, we're doing a sum, and because this is a positive, I know it's going to be positive numbers, so 37, 20, 15, and 12, and lo and behold, that's the one that works. So you get x plus 6, x plus 6, and you go, oh hey, that's just x plus 6 squared. Okay, so even if you don't recognize it, our 3-step process will always work. With these, it's a different story because now they're cubics, right? So you no longer have a quadratic. You've got a cubic, which is more pieces. So memorizing these two is helpful, but you know, they don't show up a lot. It's not the worst thing in the world if you can't memorize them. And those are all the special types of things that you're going to have to be factoring, and that's everything for this video.